All right, we're going to get up here. Cool. Good afternoon, everyone. Welcome back from lunch. As introduced, my name is Julie, and I'm going to be talking about testing strategies in Angular, specifically Angular 2 today. And if you were here last year, that's a very similar title to the talk that I gave last year for testing strategies in Angular. But we've updated a couple things for final. And so today I'm going to focus on what's changed, what we're thinking best practices are going to be in final, and taking a little bit of a look at a slightly more complicated example of code you might want to test. So we'll do a lot of exploring and reading through code and looking at some strategies there. That said, there's still a lot of things that we're hoping to work on post-final, so I'll give you a couple of updates on what those are. And we'll talk a little bit about some of the behind-the-scenes magic that happens in our testing utilities. So before we really get started, I want to say a word or two on setup for testing. There are lots of different libraries available for writing tests, lots of different ways to run them, lots of different frameworks that are available. And our goal is to give you a good set of defaults with our tools like CLI and with our test seed repositories. But we also want Angular's testing utilities to be flexible so that if you really love some tools, you can work with those. We're not 100% there right now. There is some magic that goes on behind the scenes that makes some of these things work better than others. And I hope that by the end of the talk, you'll know where that is. So if you do want to go and mess with it, you'll understand what you need to do. But for right now, let me just talk through what our stack is and why we've chosen those and why my examples will be with those. So the first thing is TypeScript, obviously. And you've heard a lot about TypeScript over the past few days. And many of you are probably already using TypeScript. But I just want to point out that beyond just the simple things that you would think of for what you get from a typed language, TypeScript also has the ability to catch lots of little errors like this. This is something I really wrote last night when I was kind of jet-lagged. And if you look at it, you can see that I have a variable that I declared inside of a for loop when it should have been outside. And that's the sort of thing that with plain JavaScript, you would have had to have really rigorous test coverage to be able to catch, and it might not have been immediately obvious. But here, my editor was able to tell me immediately, and if I didn't have an editor that was aware, when I tried to compile, I would have been able to get it immediately. So when you're using TypeScript, you get a lot of support for little cases like that that make testing easier overall, because you don't have to be so worried about all of those little things. We use Karma as our test runner, which is supported by teams at Google and very highly used and has been used by the Angular team for a long time. I want to highlight that Karma is just the test runner, and so it hooks into different frameworks for what's actually your test syntax. So when a lot of people see Karma, they'll think that it's sort of the whole package, but it's usually set up by default with something like Jasmine. What Karma takes care of is instantiating your browser instance, managing watching files when they change, and sending feedback back to the console. And with TypeScript, now that we've introduced build steps into our process, there's a lot of different ways that you can set this watching pipeline up. The way that I've done it in my repository, which there'll be links to, is I have tools that just build TypeScript to JavaScript, and then I set up Karma that directly watches the JavaScript. There's also plugins that you could use to, for example, compile the TypeScript in the browser, or have a plugin for Karma that would do that compilation step. But that's sort of duplicating part of your build process in your test pipeline. So I like just directly watching the JavaScript and letting other processes take care of the compilation step. And then I chose this photo just to show things that you can do once you have your tests running in an actual browser, which is most usefully, you can step into the debugger and use all of the goodness that you get from Chrome debug tools to go in and look at your test. And you can see here that I have a component that's actually rendering in the page, which is helpful, and I'll talk more about that later. OK, and the final piece that we're using is Jasmine as our test framework. We like Jasmine because it's really good for test-driven development, and it has a really simple and clean API. But we know that a lot of people have a lot of different opinions on what test frameworks they want to use. And so we are trying to be able to support more. If you haven't seen Jasmine, it's based on functions that describe what your application does. So you can nest descriptions And then inside of each, you will have it blocks, which are your individual test cases. And I'll be talking about these a lot and using this syntax as we go. Cool. So now let's dig into what's actually changed with Angular 2. One of the big changes that I'm sure you all know about is ng modules, which provide a way of bundling pieces of your application together. And it turns out that this is what we really want for tests a lot of the time. We want a test to be able to say, this is what I need from Angular's dependency injection. These are the components that I'm going to need to work with. These are the pipes that I'm going to need to work with. And so we've reorganized our testing infrastructure around modules so that each test gets its own test module, which is a little bit special from just a normal ng module. And that's cleaned up at the end, and you get a brand new one. So you can instantiate these like you would normal modules. You'll see a lot of the same syntax. So we're all just testing JavaScript at the end of the day here. And sometimes you don't need all of the infrastructure that you can get from the testing utilities that we have. So let's look first at what a really simple test might be. So when we're talking about dependency injection, the classical example is we have a car that has an engine and some tires. And because we're using nice dependency injection patterns, we have these passed into the constructor as opposed to creating new ones inside the test, which would make it really hard if we wanted to use some sort of mock tires, for example. So we can have a plain old JavaScript test where in our own test function, we'll take care of creating a new car and making the engine and tires that we need to pass into it. And this is fine and works well, and you can do this for a lot of your Angular services. But it starts to get tricky when your dependency injection becomes more complicated. And you have, for example, a lot more things in your constructor, and some of those actually need their own dependencies to create a new version. So you could go in your test and write all of the code needed to new up all of this, but then you're not really testing your module setup. You're not testing your DI setup, and you're also kind of doing extra work. So in comes the testbed, which is the main entry point for almost all of the APIs that Angular provides for testing. Testbed has a collection of static methods that let you configure, override, and use that testing module that you're going to get one per every test. It also has a couple of setup functions that I'll show you later when we're walking through some code that do global setup and declare what type of platform we're running on, similar to how when you're bootstrapping your application, you have to say that this is running on the browser platform or on a different platform. And there's a little bit of magic going on behind the scenes with Testbed to make sure that those static methods always go to one same object and that that object is cleaned up after every class. So we have the testbed. The first thing that we're going to need to do with it is configure our testing module, which has the same module properties that you would use if you were using an annotation. And then there's also this inject helper function, which will let us actually use the dependency injection that's been created by our testing module. So back to our car example. Instead of creating everything new ourselves, we can use a before each block, which is a Jasmine function that just runs before every test, and configure the testing module with the providers for all of those things that we need. And let's say that the battery class, for some reason, is expensive, and we don't actually want that to run in our tests. We can mock that out at this point by, instead of providing battery with its default class, using a mock one. And then inside our it block here, we'll use that inject function and tell it that we would like to get an instance of car. And this will use the same machinery that Angular uses when it does normal dependency injection. Now, you might be thinking, if we go back here, you're still typing out everything that you need for your dependency injection at some point. And Angular is taking care of it a little bit better behind the scenes, but that's still a lot of boilerplate. But this is all just modules. So we can import a car module if we have something that's already setting this up, and then mock out the providers that we don't like from here. And this is useful for testing and also useful for thinking about your application. A lot of the times when things are difficult to test or seem like they're getting kind of too verbose or tricky, it's a sign that maybe there's something that could be refactored in your application. So to make our applications more testable, it's useful to think about if you don't have a big enough module or a small enough module to easily test the pieces that you want, maybe that's a comment on your module size. And then one final thing that we can do with the testbed is we can override a lot of things. Specifically, we can override properties from the module before we actually instantiate it. So if we needed to, for example, say that we imported a separate battery module and we just wanted to get rid of that, we can use the testbed's override module function to just remove that import, and then we can provide everything that we need in whatever way we would like. So that's a little bit about how to use Angular's testbed for dependency injection, and that's how you would maybe be testing services most of the time. But we get to really interesting stuff when we want to start testing components, because components have these complicated features where they have a template that's interacting with code, and so it's not obvious how to set that up by default. So testbed gives us the ability to compile components, which are just the components that are found in the test module that we're using, and then synchronously create components once we have them compiled. This create component function returns a component fixture, which has a bunch of utilities for dealing with things that Angular might want to do for a component. But the two primary things that we'll be looking at first are getting debug elements and a component instance from the fixture. The debug element is an Angular representation of an abstract element. So if you are writing a component library that might be used not just for the web, but for other platforms, and you don't want to tie it to one renderer, you could test at the debug element level. And it's similar to element refs, and contains a lot of the same information from those. You could also get at the native element, which I'll show you how to do as well, if you're just worried about, for example, HTML. And then the component instance is literally just the instance of the component class that you have, so you can interact directly with that. So let's actually look at some code here. So I've created this little test application that will restart. This is a component that plays a tic-tac-toe game for you. So we have a little bit of UI around the component, which lets us change players' names. Let's say we're Janet instead of Jane, with an X player and a circle player. And we can click on the boxes, and it'll detect when something has ended. Or we also want to be able to use the keyboard to interact with this. So you can press a row and then column, and it's listening for key events on the window. So I pressed 1 and 3 to hit that, and then could continue the game as follows. So we have two different components, two different interesting components that are here. There's the tic-tac-toe board itself, which is handling the key events and the clicking. And then it exports some outputs to the UI, which has the player names, lists whose turn it is, and produces some output and lets you reset when the game is finished. Let's dig into the code a little bit here. So this is a setup similar to what Angular CLI would give you in terms of directory structure. It's not quite the same, and I have a link to this code that you can go download and play around with. But we have our source folder, which has our configurations and a very simple index.html that's just loading our tic-tac-toe application. And then Angular module, which loads our board and the game component, which is the UI around it. We're going to use the Angular forms module for those name fields to get the two-way binding. And we'll just bootstrap into the browser platform for now. So first, let's look at the tic-tac-toe board component itself, since that's the child component and doesn't really have any dependencies. So we have a template, which uses ng4 to create this 3x3 grid. And then every box is bound to a getOwner function to figure out if it's currently a blank square or if it's owned by circle or X, and also has a click handler to handle a check on that specific element. If we go into the Typescript, we can see that we're going to output two different events here, one when the game ends and one when it changes turns. And we'll have a reset function that lets us interact with it, that getOwner function that the template is using, and the handle check function that the template is using as the click handler. Then we also have this special listener so that I can do the keyboard interaction. So this is listening for anything happening on the window with key down events and then filtering out for ones that are numbers. And then we have this really big function that does a bunch of logic that checks for the end game to see if any patterns have been met and who the winner is. So this is a really meaty function in terms of business logic. And we probably want to try a bunch of different situations with it. So that's a really good candidate for testing outside of the Angular component loading setup. Let me move over to the spec file here. So as you can see, we're importing that testbed and the component fixture from Angular core testing. In general, if you're looking for any testing utilities, just add /testing to the end of whichever Angular property you're on. And we're also importing this async function, which I will talk about later. For now, we can kind of leave this as magic. We'll import the board. And first, let's test that function that checks if there's a winner. So we're just going to go ahead and manually create an instance of the board class. It's a component, but it's also just a class, so we can just instantiate it. And then we'll check for the end game with a bunch of different configurations that we pass in manually. So nothing really special going on here, nothing special about Angular. We just want to do all of these business logic tests with as few other dependencies as possible so that if they fail, we get really easy to understand output and don't have to deal with figuring out exactly where the problem occurred. There's a bunch of tests that do that. OK, so that's good. We've tested that one piece of it. But if you remember, in our Tic-Tac-Toe HTML, this is not trivial templating that we have here. We're using ng4 over a couple of properties. We're using some classes. We're using these handlers for clicking. And we're using some template binding. So it doesn't make sense not to test this at all. And we want our test to be able to exercise that template in some way. So we'll bring out our testbed. And we'll make a really simple little testing module that just declares that we're going to use this board component. Now, here's one way that the testing modules are slightly different from normal ng modules. You're able to create components from anything you've declared or any transitive declarations. So you don't have to also add board as a bootstrap component or an entry component, for example. The test module will understand and look deeply into your application to find all of those. We have this little magic block that I'll talk about later, set up in a before each, where we're going to call the compile component step. And we'll wrap this in this async function that I'll dive into more fully later. But for now, you can just think that this makes sure that the operations here are complete before we move on with our test. And compiling components has to be asynchronous because components might have templates. And that means that we might have to do a XHR to go get that. So we always have to compile components synchronously. But once we've done that, we can create components always asynchronously, which is a change from some of the mid-step testing utilities that we had and makes tests look a lot nicer. So let's check that when we click on elements, we actually get some response. We get a component fixture from creating that component. And one of the utilities that it gets us is the ability to detect changes. We need to run this because our template is using that text interpolation. And if we didn't run it at first, we might not have all of the empty squares set up exactly like we need. So we'll tell Angular to run a round of change detection. Then we'll get at the native element from the fixture. So this is an HTML element at this point, not a debug element, because we're just going to be using this on the web. And we want to go in and just use the easy native calls to get elements by CSS using query selector all. At this point, we're just using DOM stuff. We look at the text content, and since we haven't clicked on it yet, it should be empty, which we represent with an underscore. And then we'll use our good old DOM triggering to trigger a click event. Remember that we need to run detect changes again, because otherwise Angular doesn't know about the click event inside the context of our tests. And then we expect that the content has changed. Great. Now, we had that reset function on the board component, and we'd also like to be able to tell if we can do that and get all of our squares back to blank. So we can directly go and grab the component instance from the fixture and manually call reset. Again, run around to change detections and expect that we're back to blank. So that's the sort of test that you would write to exercise that the template is working properly with its inputs and with event handlers and connecting with everything on your component. We also want to test those keyboard events that I was trying. And this gets a little bit trickier because making keyboard events isn't quite as clean as making click events. But it's not too bad. We'll instantiate a couple of keyboard events and dispatch them to the window, because remember, we're listening just on the window, not on a specific element here. And this is a place where having a test runner like Karma that opens a real browser and puts your elements into the DOM is really helpful, because you actually do have that window and all of those window APIs available. So we'll dispatch pressing a 1 key, simulate pressing 1, simulate pressing 3, run around of change detections, and again, go in and get a native element and assert something on its text content. Cool. So there's a lot more things that you could test with this grid, but I think for now we should move on to the wrapper component. And this is interesting because it's using child components, but we don't really care about the whole tic-tac-toe board, right? If we just want to test all of this stuff that's going on up here, we don't really care what the implementation of the board looks like, and maybe that's something that we want to avoid using in these tests. So just to quickly get a sense of what we're actually looking at, the game component has a couple of inputs that are using ngModel from forms to bind to the player who's playing crosses and the player who's playing circles. It has a couple of simple if switches to determine whose turn it is. And then it uses the tic-tac-toe board component that we just tested, and it listens for a couple of events that emits. The event to handle the endgame, and when the turn is swapped back and forth between players. And then finally, we've got that reset button. So in the code here, you can see the handlers for our various events, and that there's not quite so much logic actually going on in this, just checking who wins the game, or declaring it a tie if there is no winner. So in the spec here, let's try to make a module that uses this game component, but doesn't actually use that tic-tac-toe board that we had before. We can do that by configuring our testing module, declaring game component as we would before. Let's import the forms module to use real forms, because we don't really mind those. And then we have this schemas line. And what this does is tell the compiler, when you're compiling these components, don't worry about any tags that you see that you don't understand. So it'll just pass over that TTT board tag that it sees and say, I don't know what that is, but you told me not to run any errors, so I'm just going to go ahead and make it. So this will then validly compile our components, which again we have in this before each block. And we can test just that everything renders and that it contains the right type of text. So let's make sure that we have those events hooked up decently. So we'll create our component fixture again, and let's make sure that if that tic-tac-toe board that we're not rendering does emit an event that tells us it's the end game and no one won, we should say that there was a tie. The component fixture lets us do this by getting at the debug element, and the Angular debug element knows how to trigger event handlers. And this can be any event handler. So we'll just pass in the string with the event name in this case and create whatever event we would like. We're doing a little bit more work here to get at the actual element for the TTT board. Debug elements, since they're not HTML elements, don't have a query selector all function, but they do have this query function, which we export. And we provide a couple of ways to automatically query elements. One of them, you can use CSS. Great. So we'll use that. This returns another debug element, not an HTML element child. So we have that, and we can trigger the event handler of endgame. We'll run our favorite detect changes function, and now we can assert things on the output of the event. And we can run a similar test triggering a different event, because again, we can just pass in any string we'd like here to synthetically create these events to make sure that when we call the turn swap event, the text changes to correct turn. So those are the events that are coming from the Tic-Tac-Toe board itself. There's also that form up above where we're using the ng model. An ng model can be a little bit tricky to test, and I will talk about this later. And forms in general are hard to test because they have a lot of asynchronous behavior that's in them by default. But one thing that we can do is make sure that our data binding from our component instance down to our template is working properly. That's pretty easy, and we can do without too much trouble. So we'll just make sure that everything is sane at the beginning of the test. So Jane is the default name for the first player, but we want to change that. And we'll go in directly on the component instance and just change that property to a new name. We can run detect changes and expect that the output is what we would like. So I think that's enough code right for the moment. And that gives you a sense of some of the things that you can do using the testbed, the component fixture, and the debug elements to robustly test that your template and your various components all work together. So now we're going to take a little side trip to talk about that mystical async function and the zones which back it. And I've included a link in the slides to a presentation that I did at ngconf in Utah a few months ago, which goes into this into a little bit more detail, if you'd like to hear more. I think it's always useful to think about zones more than once, so I would recommend both doing that and looking at this. My slides have overlapped slightly here, but I think you still get the idea. So this is the JavaScript event loop. We're talking about this because Angular has this library called zones that it uses for things like knowing when to run change detection or being able to tell testing frameworks when it's stable, which is my particular interest. And zones is all about managing asynchronous events and understanding when they're related and when they come from the same context. So as all of the web developers here know, JavaScript is a single-threaded program that runs with an event loop. The call stack down in the bottom here is our code that's running what we consider synchronously on a stack. And at the end of a little loop of the call stack, your code will wait until it hits a message from the callback queue. That could be something like an HTTP request returning, a timeout finishing, an event coming in from the user for some reason. And then you start up on the call stack that runs your code again. And there's one additional little piece to this, which is the microtask queue. When you use things like promise.resolve, anything that resolves immediately, that needs to be run after your call stack so that you don't get strange, unexpected behavior, but also needs to be run really quickly. So that's put onto this microtask queue, which is always run immediately afterwards and before the next message from the callback queue is handled. And in modern web frameworks, there are a lot of different things that can cause all of these various asynchronous events to happen. And so what zones does is it wraps all of these monkey patches, all of the different possible things that could happen to create asynchronous events, and lets you manage them with a nice API where you can tell zones, I'm going to run something in this and tell me when other things happen in that context. So in practice, zones is just a library that you can get from NPM or from GitHub and include in your page. And it gives you a global zone function and a root zone. You can interact with zones by forking them and giving them a series of properties that say, what behavior should this zone produce? So for this really simple one, let's just tell it that it's got a name. We'll call it my zone. And then you kick off something by running it within the zone. So we can add an event listener for clicks to this button with the handle click. And then when that handle click function is called, which could be much later, it'll still be in that same zone that you set up. So if you log the current zone name, you'll get back to my zone. If you set a different click handler in a different zone, you would get whatever that other zone was, even clicking on the same button. So we create new zones by forking from parent ones, and zones form a hierarchy in your application where events can be handled further up the chain if they're not intercepted immediately. And the reason you might want to do something like this would be, say you have an application on your page, which is your main application, and then there's also a help pop-up box that's developed by a different team, and you want to do some special stuff with with error handling. But you don't want to have to deal with any errors that are coming from that other help pop-up that occasionally happens on the page. So you can run your main code in one fork of the zone, and then create a separate fork for the help pop-up. And any HTTP requests or timeouts or event handlers that happen there won't affect your main application. Going back to our event loop, we can also think of all of these asynchronous things that are happening and waiting on the callback queue as tasks. And Zone introduces this concept of a task and lets you manage various task queues. So there's the microtask queue, which we talked about a little bit before. We also have the concept of a macrotask queue, which I've put in air quotes because it's not exactly a queue, because some of these things don't return first in, first out, right? You'll have timeouts that were registered later than earlier timeouts, but were shorter, returning first. And then there's things that are registered as event tasks, which are sort of even less of a queue because they might not go away after they've been handled. But Zones lets you understand when something is added to these queues, when something is removed from them, and when they're depleted. And this gets back to why I'm talking about this all right now, which is those asynchronous functions. So in testing, what we want to know essentially is, when are my microtask and macrotask queues empty? When can I safely move on with my tests? And so we can do this with Zones. The way that you would implement something like this, if you're interested in going and trying it out, which I highly recommend because I think playing with zones is the best way to understand them, is by passing in this zone spec property. So when you fork a zone, you can tell it what its name should be, arbitrary properties, and then what to do on certain events, like when an error is handled, when a task is scheduled or canceled. So thinking about the example where you have a main application and a pop-up, you could have a custom error handler for your main application, run whatever your app's starting function is inside that zone, and then create a separate zone and run other code there. And this that you're passing in to forking the zone is that zone spec. So for unit tests, we have this async function. And the problem that we're trying to solve is that it's difficult to know when all of your code in your unit tests is completed. So you've probably seen frameworks that deal with this by, for example, passing in a done function, where the developer has to manually call when they're finished and let the framework know. And this works pretty well, but it's easy to forget things like calling done.fail or calling it with an error message if something has gone wrong. So all you'll get if this test doesn't work is just a timeout. Another thing that we've tried is returning promises from tests, which has similar issues where if you forget to return inner promises, you would never get to some of these expectations, or you wouldn't be assured that you would get to them before your test had completed. So async solves these problems by using zones to understand all of the asynchronous events so the developer doesn't have to manually keep track of them. And behind the scenes, it's essentially for every test, every time it's invoked, it creates a new asynchronous test zone that handles those queues of microtasks and macrotasks, and when they're empty, it lets the test framework know that you're finished. Right now, this is optimized for working with tools like Jasmine and Mocha, in that it can wrap around a test function. And there's also some special handling for Jasmine that you should know about if you're forging out to experiment with this on your own. We discovered that we want functions to run in the same zone when you have a before each block and an it block, because, for example, if you set up a component inside a before each block and then run tests that interact with that component in it, those all need to be in the same zone. If we forgot about asynchronous events, because they were in the zone of the before each block and the it block didn't care, it would exit too early. So if you want to understand what's happening with that code, I highly recommend going into the zone repository. There's a couple fairly small files that define the zone specs for how all of these work that could be easily adapted to any other framework that you wanted to work with. So let's put this in context of what it might actually look with an Angular service. I updated the slide to Celsius just for London. We're testing that we have a service that gets temperature, and let's say that this is asynchronous service because it needs to call out to a meteorologist, and that might take some time. So we can inject the weather service, as we did earlier in this talk, get the temperature, and then make assertions on that. And notice that here, we're not calling done anywhere. We're not returning any promises. We have two different asynchronous things going on, and we're assured that both of those will complete before the test exits. And there's links in the slides to a full example of this running on GitHub. There's another way, another helper that Angular provides for dealing with this called fake async. And instead of monitoring those queues of microtasks and macrotasks, fake async actually takes them over and lets you manually say, OK, now run all of the microtasks. So this happens actually synchronously. Of course, this means that it doesn't work with things like XHRs, where we can't manually run them ahead of time because there's just nothing there. But it will work for timeouts and microtasks. Again, pretend we have a class that has a countdown, and the countdown, after a certain amount of time, using set timeouts, will reduce its number until it gets to 0. So we can set it up, run expectations on it, and then use the tick function that's provided with fake async to manually move time forward by that many milliseconds. And repeat this until we're all finished. All right, so close aside on async and zones, and let's get back to component testing. So let's apply this to an Angular 2 component. Say we have this simple little async component, and all it's got is a click handler and some text interpolation. And when you call that click handler, it does, and it increments, but it increments asynchronously. So this could be a promise resolve, or this could be waiting for an XHR, or this could be a timeout. A test for that might look something like this. So first, we've got that async helper wrapping around everything. Then we have our good old creating components, assuming that we've already set up the test bed. And we have our change detection run. And so then we'll trigger a click event by calling element.click here. So now we have a problem. We've triggered click, but we don't know when it's going to finish. We know that our test isn't going to exit until it finishes, but we need to run some assertions. So just knowing that our test isn't going to exit isn't good enough. We actually need a way to get a hold of the time when that has finished. And fortunately, component fixture provides a way for us to do this with a function called whenStable. This asks Angular, essentially, to wait, using Angular's own internal zones, for when that component doesn't have any pending tasks. So we call component fixture whenStable, then we can run one more round of change detection and run our expectations, and the text will have changed. You might notice that we're calling detect changes an awful lot here. And there's a utility on the component fixture called auto detect changes, which can help out with this. Unfortunately, this doesn't work in all situations because, for example, if you just change a property on a component instance, that doesn't trigger any functions or allow any hooks where we could know that we need to automatically detect changes. So you may still need to do some manually, but this will handle anything coming from events for you. Another way that we could have dealt with this is just using fake async. And instead of asking when the component is stable, calling the tick function to wait for any asynchronous events. And if we had a particular time frame that we were looking at, we could pass in a number there to do something specific. So this brings me to a question that I've talked about with a couple of you at this conference, which is testing ng model, which is very tricky now. And this is because ng model is always asynchronous, because it might be listening, it might have to listen for debouncing information about typing. And to make things consistent in the latest iteration of forms, we've made it always asynchronous. But that means that if you're trying to test that when you change the text input on your template, your component instant changes, you need to do a lot of dispatching events, waiting for things to be stable, and knowing run-to-run change detection. So here's an example from ng model's own test suite that you can take a look at. But fortunately, I think that in most cases, this isn't something that you'll really have to test yourself. You can make sure that when you change your component instance, the view is updated, and that's a much more simpler flow, and trust that ng model does the right thing, and that we have tests for it when you're flowing the other way. So as an overview of what we talked about for component fixture, you can create components using the testbed after you've compiled, which is always a synchronous step. You can run change detection. You can wait for things to become stable, asking Angular when things are done. You can get at component instances, and you can use debug elements or native elements from the component fixture. So we're really excited to see how you guys start using this to test and come up with best practices. But we know that there are some things that we could be doing better that we're already starting to think about. The first one that is at the top of my mind is utilities for working with observables. We've heard a lot about observables at this conference, and as they become more prevalent, they become something of a problem for our testing frameworks, because many observables will set up polling timeouts that aren't easily tested with the async utilities that we have now. The observables framework itself has an interesting setup where essentially it creates a log of events as a string and then looks at that. And we're looking into how we can use utilities like that to make a good setup for testing for Angular. And then we also would like to improve the ergonomics for dealing with asynchronous functions and dispatching events, from simply helping with dispatching events on different browsers, which is still a bit of a pain, to maybe allowing you to use async await and other language features that are coming down the pipes to make this all look a bit cleaner. There's also a couple other testing utilities that I don't really have time to talk about, but that are available for specific subsets of Angular. So like I said before, if you're looking for the testing utilities in general, just add /testing to the end. Router and HTTP already both come with utilities. In router's case, which helps you mock out and spy on what your route changes would have been, and HTTP will let you set up mock responses from your connection. And then in the little bit of time I have left, I want to talk about end-to-end tests as my original entry. So let's go back and look at the code that we have for our application here. So this is the Tic-Tac-Toe app. We can see in our package.json that we're using the latest Protractor, which now comes with much improved TypeScript support. So we have an E2E folder for TypeScript tests, and we're importing these global variables that Protractor uses. And that means that we can get nice auto-completion now from element. I would have to add a string there to make TypeScript happy. So it's much easier to know what functions are available and write tests. And we have a simple Protractor configuration file here, our config folder. This is all very similar to what you would do for end-to-end testing any Angular 1 application. We also have this magic string here, use all Angular 2 application routes. And what this perhaps poorly named flag tells you is wait for every Angular application on the page to be done before we're synchronizing. Angular 2 has really good utilities that let us do this, and that means that your tests will be less flaky because we know how to wait for every application to be, for some degree, stable. So let's actually run these tests to prove that they work against Angular 2 app. And I've introduced some lag here, but what these tests are doing is running once using click events and once using the window, dispatching key events to the window, so we can determine that that runs both ways. And this is a really good application to show how you would want to have some really quick tracer bullet tests like this that don't test every single possible permutation of your tic-tac-toe board, because that would take forever, but make sure that the whole flow works and that all of your components work together. All right, that's about all the time I have. So as a quick wrap up, for end-to-end tests, in your configuration file, use that all Angular 2 app routes flag, and it'll work with zones. We're still working on figuring out what to do with by binding and by model for Angular 2, but hope to have some updates on that soon. Thank you very much.